Okay. All right, so my name is Bethany Sargent. I'm with the Clean Water Initiative program, and I'm joined by Emily Bird and Helen Carr, who will be presenting this morning on Vermont Clean Water Projects Tracking. So we have a number of folks online and a few folks in the room. Thanks everyone for joining us. For those online, if you have questions, it's fine to ask them during the presentation. I just ask that you ask your questions via instant message so that it doesn't get too confusing in terms of having a number of people speaking at once. So if you ask your question via the instant message through Skype, I can just voice it in the room for you. So I will be fielding those questions, and we'll definitely leave some time at the end for questions. We have a couple other folks just joining us, so again, thanks for being here, and I'll go ahead and turn it over to Emily.
Hi everyone, thanks for the opportunity to share some information about our clean water tracking. I'm Emily Bird, and I work in the Clean Water Initiative program, and I oversee all of our tracking and accounting and coordinate across agencies to track our clean water projects. And I'm joined with my colleague Helen, who is also working on our tracking, and she oversees tracking for ecosystem restoration grants and has expertise in the stormwater road sector. So we're going to talk about our overarching tracking system, the different things we're tracking and why, including our nutrient tracking for restoration plans known as total maximum daily loads, and our investment tracking that we report to the legislature annually through our Clean Water Investment Report. And we also have a new feature available to share with you all today. It's what we're calling Phase 1 of our Clean Water Project Dashboard, which begins to make more of this tracking system available to the public through an online dashboard. So we're going to share some information and walk you through that towards the end of the presentation. So in Vermont, we are tracking our clean water activities, and this was all brought about by a couple of requirements that came through the Lake Champlain Total Maximum Daily Load, which is a restoration plan for phosphorus in Lake Champlain, and also the Vermont Clean Water Act that was passed in 2015 that set forth a number of accountability requirements related to our progress meeting our clean water goals statewide, related to the full picture of all clean water activities and also how the state is investing in clean water and what we're getting out of that investment. So we've been working over the last few years to develop a tracking system for all of these activities, and we're working to capture the results of all clean water activities across the various sectors that are involved. This is an all-in approach, and every sector has a role to play in addressing clean water issues in the state and also protecting our high-quality waters. So we have been working with our partner agencies and other partners to develop these tracking systems addressing agriculture, forest lands, lakes, rivers, roads, wastewater, wetlands, and stormwater runoff from developed lands. And we're primarily tracking through our funding and regulatory programs, because those are some of the avenues where we know we can set up some reporting requirements and capture a full picture of the work that's being implemented. We're also working to capture work that's done voluntarily and through other initiatives where we can, but this is really the major focus of our tracking is through funding programs, primarily state grant programs, as well as regulatory programs that will be rolled out over time for clean water related to agriculture, stormwater, and wastewater. And I'll just mention that there is overlap between these two things, and really as these new requirements are rolled out through these regulatory programs, we are working to align our funding programs to help cover cost of compliance for all these different sectors as well. So over time, these will become more overlapping to support cost of compliance. And so first of all, we are tracking this to measure our progress meeting these nutrient pollutant reductions that are required by pollution control plans, also known as total maximum daily loads. That's a federal Clean Water Act requirement where a water body is not meeting its standards. You develop a TMDL to identify the pollutant reduction targets that will allow that water body to come back into meeting standards. And so in Vermont, our state is divided into 4 major basins. We have Lake Champlain in the top left corner in the dark gray. We have Lake Memphremagog in the upper eastern portion of the state. Along the eastern side of the state is the Connecticut River Basin, which drains to Long Island Sound. And we also have the Hudson in the bottom left corner of the state. And primarily phosphorus is the pollutant of concern for freshwater, which is why for Lake Champlain and Memphremagog, those water bodies are not meeting standards, and phosphorus is really the pollutant of concern. So we're looking to track phosphorus for those 2 basins, and then nitrogen is the pollutant of concern in the Connecticut River as it drains to Long Island Sound, which is saltwater, and primarily nitrogen is the pollutant or nutrient pollutant of concern for saltwater. Not to discredit some of the local water quality issues all throughout the state that we're also working to account for, but those are some of the major TMDLs that are driving our nutrient reduction efforts in the state. And so when we're talking about tracking TMDL implementation, we're really looking at the full realm of funding and regulatory programs, and we're developing systems to capture all of those results and quantify nutrient pollutant reductions associated with it. And a major reason why we're doing this started with the Lake Champlain TMDL. The Lake Champlain TMDL has an accountability framework which establishes check-in points to make sure that over the roughly 20-year implementation period that we're making adequate progress reducing phosphorus to meet the TMDL target load. And so that accountability framework sets forth a process where we have the TMDL at the top establishes our overarching phosphorus reduction targets. Then in Vermont, we have what is known as tactical basin plans, which describe how we're going to be implementing the TMDL on the river watershed scale. And those tactical basin plans establish interim phosphorus planning targets for a 5-year period, and they also identify priority actions that are necessary to meet those reduction targets. And as those actions are implemented through our regulatory and our funding programs, we are working to capture those results and estimate the annual average phosphorus reduction associated with those activities. And then we will measure our progress against the TMDL baseload and targets. And on a 5-year rotating basis, EPA, the U.S. Environmental Protection Agency, is going to be issuing report cards on how we're doing. And there's going to be every 2.5 years an interim check-in point and every 5 years a final report card. So we're working to prepare to be able to provide data on our progress in order to support EPA in making that determination. That's one major driver. Another driver is the need to track the state's investments in clean water, and that really just focuses on the funding side. And that does capture funding that is provided to support compliance with regulatory programs. But when we're tracking state clean water investments, we're talking about state investments through state agencies in clean water projects. And so that's the main focus of our investment report, which we're going to dive into a little bit more. So Act 64, the Vermont Clean Water Act that was passed in 2015, set up an annual reporting requirement that the state would work together across agencies. This really includes Agency of Administration, Commerce Community Development, Agriculture, Transportation, Natural Resources, to coordinate on how we track our clean water progress and the state investments in clean water projects and put it all into one report. So this is really the first time. Last year's report was the first time that we were able to bring it all together into one place and start to measure our progress. So the 2016 report, since that was the first time we brought all of those project results into one report, we look at it as establishing our baseline. So where are we starting from? This is a work in progress. Not only is this the first time we've brought all these data together, but our systems that were developed to track these data are also very new. And so it was a new exercise and established our baseline for us to measure our progress moving forward. The 2017 investment report, which is available online, and there's a link right here, and I believe Bethany also sent out a direct link to it. The 2017 investment report is the first time that we have more than 1 year of data. So we're starting to measure our progress over time And as we have more years of data, we can actually start to look at how we're doing with trends. Are we moving in the right direction in certain areas, or do we need to focus efforts more in other areas? So it's a work in progress, but we're starting to see some improvements, and it's really exciting to see it all come together. So throughout this presentation, I'm going to be sharing a bunch of graphics from the report, and I have page numbers that reference specific pages in the report on the bottom of each slide. So if you're interested in following along or looking back at those sections of the report, feel free to take note of that. So I wanted to just first describe the different major chapters of the investment report. Again, we're just talking about state funding, not the whole picture of TMDL implementation, but the piece of it that is supported by state-funded grants. So the first chapter of the report covers outreach and technical assistance that is intended to support Vermont's clean water efforts. And that could range anywhere from working with local partners to raise awareness of best practices to improve water quality. It could also involve working with municipal road foremen to make them more familiar with new upcoming regulations so that they're prepared to comply with water quality regulations. There's a whole range of outreach and technical assistance activities that are summarized in this report. So we talk about our extent of outreach, organized outreach events like workshops and trainings and hours of education provided. We also summarize the technical assistance efforts of all the different agencies in helping local partners implement clean water projects. That's the first major chapter of the report. The second chapter discusses investments made in clean water projects in State Fiscal Year 2017. So that's everything from July 1st of 2016 through June 30th of 2017. So any grant agreements that were awarded or contracts that were signed or loans that were financed to municipalities within State Fiscal Year 17, those are summarized here. And there's lots of different ways they're displayed. We display it by total dollars awarded, by funding source, because there's many different funding sources that are necessary to meet our clean water goals. We also share dollars awarded, the geographic distribution by watershed and county, and by sector, and the different types of groups that are receiving grants and contracts and loans. And then the third chapter summarizes the results of projects that were completed during that same reporting period, the State Fiscal Year 2017. And that is where we start to quantify the results of those projects. So they're more like the results you can hold in your hand. So acres of buffer that are restored, or road miles with drainage improvements, those sorts of results. And this year we also added a new feature where we summarize the co-benefits of those results. So not just TMDL implementation and nutrients, but things like flood resiliency, hazard mitigation, public health and safety, habitat function. So highlighting all of the different benefits that these projects bring to the table. And then the final chapter of the report covers the environmental outcomes, also known as the nutrient pollutant loads that are reduced by these projects. And I'll talk a little bit more about that once we get there. But it's a work in progress, and we're not able to quantify a nutrient pollutant reduction for every single project, but we're moving in the right direction. Okay, so I talked a little bit about our outreach and technical assistance measures. I'm highlighting here a bar graph that shows hours of education provided by different state agencies and partners in State Fiscal Year 17. And outreach did increase mostly across the board from 2016 to 2017. There's been a real push to make sure we're conducting enough outreach so that the public and our partners are familiar with what's happening in terms of new regulations, funding needs for clean water, and best practices for addressing water quality issues. The next chapter of the report summarizes our investments in clean water. And this year we also have a new scorecard, which is part of our executive summary that provides very high-level summary of some of the measures that are reported in the report. So this graphic here shows our four major basins of the state and how dollars were awarded by sector in those different parts of the state. And from 2016 to 2017, thanks to all of the work establishing new funding sources for clean water, dollars awarded to clean water projects increased by 114%, so more than doubled the investment in clean water projects, and that's expected to increase again next year. And then the next important part of the report, we're getting into the project outputs or results, is the project development process. So understanding that we can't just invest in construction of projects. We really need to invest in that project development process so that we have high quality, cost-effective projects to implement further down the road. So every year we're not just investing in construction, we're also investing in things like planning and assessment, project prioritization, and design work so that we can make sure we're investing once we get to implementing in the best projects. So in State Fiscal Year 17, state-funded assessment and planning projects identified 176 priority projects that are recommended for future design and/or implementation. Not all projects require design. Some of them, like, for example, agricultural practices like cover crop. You don't need to do engineering and design in order to implement. So we don't always require design, but some things like a stormwater treatment practice or wastewater treatment facility upgrade will certainly require a number of steps to design and implement. We also, through the different partners, the municipal partners and the regional planning commissions that are conducting road erosion inventories that will be covered under the new municipal roads general permit for clean water, 116 road miles were assessed and identified for future improvements. And we also, state-funded projects resulted in 22 preliminary designs being completed and 44 final designs being completed. So these projects are expected to feed our future implementation work. And then now we're getting into the results of projects that were implemented. And here I have all of these check boxes. These are combined all of the different benefits that these construction or implementation projects bring to the table across the different sectors. So of course we are making a lot of progress implementing our TMDL requirements, but we're also implementing some of the requirements, the regulatory requirements of the Vermont Clean Water Act. This supports compliance with required agricultural practices, new municipal stormwater permits, including municipal stormwater permits for developed areas as well as roads. It supports compliance with municipal wastewater discharge permits and compliance with the combined sewer overflow rule. We also have improved flood resiliency and flood hazard mitigation for public health and safety, outdoor recreation and tourism, boosting property values for clean water, and supporting agricultural working lands and improved habitat function. So there's a lot of different benefits that clean water projects can bring to the table, and we're starting to do our best to try to capture all of those benefits in how we measure our progress. So if you are looking at the investment report, there is an executive summary in the beginning of the report, and that features a new scorecard. And by sector, we have a summary of all of the results of projects that were implemented. So this first slide here shows the project outputs of agricultural pollution prevention projects, including the acres of cropland that were treated by annual conservation practices like cover crop or conservation tillage, acres of cropland that were treated by crop rotation and forested buffers, and the number of barnyard and production area practices installed, and acres of water quality protections within conserved agricultural lands. So we show these data for 2016 and 2017, so you can see how we're making progress over time. And we also show for each of these measures which co-benefits they provide. So pretty much all of these agricultural practices are going to provide benefits for TMDL implementation, Act 64 compliance, and required agricultural practices compliance, as well as supporting the working landscape. And some of them, like buffers and ag easements, agricultural easements with water quality protections, will also provide flood resiliency benefits and habitat benefits because they require very extended buffers, forested buffers. Okay. And then the second piece of this are the environmental outcomes. You'll see a little fish icon in the top right that indicates that we're talking about the actual pollutant load reductions that were achieved. So here we also present the pollutant reductions that were quantified in 2016 and 2017. And I want to highlight something that's really important, and we'll get into more details on this a little bit later in the presentation. We are doing our best to quantify the results of all of the projects that are implemented. However, there are some limitations. It could be data availability, or where the project is located in the state, or lack of understanding of the performance of that type of project that limits us in our ability to quantify everything. So here I show that for annual conservation practices, we were able to quantify a pollutant reduction for 53% of the acres that were implemented in 2017.
Question from Charles Baker online. He says, I note that federally and locally funded projects are outside the scope of this report. Is there an intent to capture those investments and their benefits in the future? If so, how and when?
Yes, certainly. There is an intent to capture the results of federally funded projects, especially in the agricultural sector. The U.S. Department of Agriculture Natural Resources Conservation Service, NRCS, is the major funder of agricultural projects in the state. And in State Fiscal Year 2017, they awarded $22 million to clean water projects in Vermont, which is almost the amount of all of the dollars we're talking about in this report. So it's a substantial investment, and we are working with Agency of Agriculture and NRCS to be able to capture the results of those projects. And there's this new database called the Agricultural Partners Database, which is not fully online yet, but once it is online, that database will receive data from NRCS on their projects, and then they will send those data to DEC, to us, to quantify the pollutant load reduction for those projects. So you can expect that once we're able to capture more of those projects, that a lot of these results will increase significantly. So that is a work in progress. You also mentioned other local projects. Municipalities play a huge role in meeting our clean water goals, especially in Chittenden County. There's a lot of large towns with a permit called the MS4 permit, or the Municipal Separate Storm Sewer System. I think I got all the MS4 permit, where they will be implementing phosphorus control plans to meet additional load reductions, and we're working with the stormwater program that oversees that permit to be able to capture the results of all of those projects. Yep.
Andrew Engelhardt from Lake Carmike Campers Association. I noticed that it's almost a 50% reduction in the total phosphorus reduced from 2016 to 2017. Mm-hmm. I don't understand why that's going down with all your extra efforts.
That's a really good question. Part of it is that we aren't able to quantify all of the projects that were implemented. Another piece of it is that USDA and NRCS, the federal funding available for farmers, they are prioritizing certain areas for federal funding. One of those areas you can see where we have a 0 here is for crop rotation. So the Agency of Ag looked at, okay, what is NRCS expected to be funding with this additional money that we just talked about, and where can we fill in some of the gaps? So while the pollutant reduction for field practices went down this year, you'll notice that the number of barnyard and production area practices that address polluted runoff coming from barnyard areas, I more than doubled, or almost doubled, between 2016 and 2017. So when you couple the state and the federal funding, it's likely that the total level of effort actually increased. We just don't have those data yet, but we will soon.
Could you go back to your previous slide? So why did you have the data for 2016, but you don't have the data for 2017? Data collection.
I am going to get into more details, because a big part of it is where those projects are located. And so I'm going to explain that a little bit later on in the presentation.
Okay.
That's a really, really good question. Thank you. Okay. So the next sector that we summarize is natural resource restoration projects, and this includes everything from river and floodplain restoration to forest conservation and conservation practices and lake shoreland work. And so we summarize here our project results from 2016 to 2017. Almost all of these projects provide benefits for TMDL implementation. The Lake Champlain TMDL has a load allocation specifically for streams, and they also provide enhanced flood resiliency, outdoor recreation, and habitat function. So we report here on acres of forested buffer that are restored through buffer planting, also acres of corridor that are conserved through easements, which basically clears out the space for the river to be able to bring itself back into its natural function over time. And then acres of floodplain restored, stream miles that were enhanced or reconnected due to dam removal, 98 miles were reconnected. And 2 new measures in 2017. This was the first year that the Vermont Housing and Conservation Board contributed to this report. And they do a lot of agricultural conservation easements as well as forest conservation easements that have specific water quality protection requirements around wetland zones and riparian buffer. So this is a new measure in 2017, so we don't have data for that in 2016. And within the natural resources sector, we are able to quantify pollutant load reductions for buffer restoration because we are able to quantify the change from whatever the prior land use was to a forested buffer, and then also those buffers have the benefit of filtering runoff from adjacent lands. There's also a lot of other floodplain restoration related work that is going on that certainly has a phosphorus pollutant reduction benefit. We're just not quite there in terms of being able to quantify it, but we do have efforts underway within the rivers, working with the rivers program here at DEC to be able to quantify those results in future years. Okay, and this picture here is a picture of along the Stowe recreational path where they were able to move the path out of the fluvial hazard erosion zone and do a nice buffer restoration. The next sector that we highlight is transportation-related stormwater, or roads, and we summarize here the miles of municipal road drainage improvements. So those are practices like putting a stone line ditch in along a roadside to prevent erosion from runoff moving off of the road surface. We also have number of municipal road drainage structures that were installed. So those are things like where you have a drainage culvert and where the water flows into the culvert, it may be eroding, so you put stone lining in around there to help protect the soil from eroding. And we also have the number of municipal road drainage and stream culverts that were replaced to meet standards so that they aren't causing additional erosion issues. And where those culverts are in the stream, you have the added benefit of providing that reconnection of the aquatic organism passage and also expanding the culvert so that it doesn't cause erosion issues upstream or downstream.
At Lake Carmi, we don't have any problems, I don't think, with the municipal, but I don't see the agricultural roads. That's where we're having a lot of erosion just this last 2 weeks ago with pictures of it eroding into the lake. Do you keep any data on improvement in the roads? They would be private roads that are on agricultural land.
So
the erosion of that.
Agricultural access roads are technically tracked under the agricultural sector and included under those barnyard and production area practices.
Is there a line item for that? I tried to read it. You don't have to go back.
There isn't. It's not specifically teased out here, but I would be happy to follow up with you with some more detail about that.
Well, I mean, you don't have to spend time and money on it. So there's no line item where you're tracking now agricultural road for stormwater problems and erosion right now.
So Agency of Agriculture reports the BMPs, the best management practices that they fund, to us. Yeah. And for production area and barnyard management practices, they do list out all of the different types of practices, and one of those categories is access roads. So we are able to see how much work has been done on access roads. Unfortunately, it's counted as a count of the number of access road improvements that were made, and I don't have any data in terms of miles or acres that are being addressed, but we're working on addressing that data gap.
Okay, so is that something, and as we go forward with this, that we're going to keep track of the stormwater runoff and erosion from agricultural access roads that are coming into the streams and the lakes? So we can see how much progress we're making with all the investment we're doing.
That'll be part of looking at the status of required agricultural practice compliance on barnyard and production areas. So if there's significant erosion issues that are occurring within that production area, and I believe access roads are included in that area, then it would not be considered compliant, and they would need to address the issue. So I believe that will be addressed through the regulatory compliance avenue. But I can't speak in much more detail to that. But be happy to connect you with someone at Agency of Agriculture that may be able to help. Okay. So those are the results. Oh, and I just wanted to mention some of the benefits associated with these road-related practices. They help with our TMDL implementation, Act 64, and municipal roads general permit compliance. And these road practices also improve flood resiliency. And in some cases where you have stream culvert improvements, you're also expected to see habitat function improvements for aquatic organisms, such as fish. And this is new this year. We're now able to quantify the pollutant load reductions associated with road erosion practices, thanks to VTrans's great work in starting to track more details on the projects that they're funding. So we were able to quantify in 2017, 38% of municipal road miles that were improved, we were able to quantify a pollutant load reduction for. And in 2017, we estimate that those 38% of those road miles that were improved resulted in a 22 kilogram annual reduction. And this is very conservative because we have to assume that it's going from not meeting the municipal road general permit standard to partially meeting the municipal road general permit standard, because we don't have the baseline status documented through the inventories, but once those inventories are done, we'll be able to give full credit for these projects. And then finally, we highlight stormwater projects addressing road runoff from developed lands such as parking lots or other hard surfaces, so not so much the road sector, but other developed lands. And in 2017, stormwater treatment practices that were funded by the state addressed runoff from 86 acres of impervious surfaces. This sort of stormwater treatment helps us with our TMDL implementation. It helps with compliance with the Vermont Clean Water Act and municipal stormwater permits. And this photo is an example of where they converted a parking lot into a bioretention stormwater treatment practice. And in terms of pollutant load reductions, we saw a major increase from 2016 to 2017. Stormwater treatment practices that were installed treated 15 kilograms annually of phosphorus, and that represents 41% of the total acres that were treated. And I wanted to talk a little bit, getting back into that question of why can't you quantify a pollutant load reduction for all of the projects that were implemented. Our tracking system is still new, and it's a work in progress. And in order for us to quantify a pollutant reduction for a project, first we need to be able to understand, okay, you have a project located on the landscape. It's treating polluted runoff from a certain area, and we need to estimate how much of the nutrient pollution is coming off of the area that's being treated by that practice. And in order for us to do that, we need to have a pollutant loading rate for that part of the state. And in Vermont, thanks to the modeling work that was done for Lake Champlain and Lake Memphremagog, we have phosphorus loading rates for that part of the state. However, we do not have Vermont-specific nitrogen loading rates for the Connecticut River, so that is currently a gap. The other limitation in us quantifying all of the pollutant reductions for all of the projects implemented is having an understanding of the annual performance in treating whatever the pollutant of concern is for that type of practice. So this table, it shows a little bit faded up on the screen, but it shows here the first column is Lake Champlain, Lake Memphremagog, and the Connecticut River. So we're mostly only able to quantify nutrient reductions within Lake Champlain and Memphremagog. And then along the left-hand column here, it shows all the different types of clean water projects. And what we're trying to show is that we're slowly adding more green boxes to this table as we expand our methodologies to be able to quantify the results of more projects, but there are still some gaps. And so within the agricultural sector, we're working on being able to quantify the results of barnyard and production area management practices. We're just not quite there yet. We do expect this to be addressed in next year's report. And we're also in the process of working with the Rivers program here at DEC to be able to quantify pollutant reductions for river restoration and floodplain restoration projects. And we're also starting conversations with the Wetlands program about how we're going to track wetland restoration. So this is all a work in progress, but I would like to point out that all of the green boxes under Memphremagog are new this year, and road erosion controls are also new this year. So we are starting to paint a more complete picture of our progress. And while we may not be quantifying a pollutant reduction for all of these practices, we are tracking all of them. So once we have the methods in place, we can go back in time and quantify pollutant reductions retroactively. So in the State Fiscal Year 2017, this graphic shows the number of projects that were constructed or implemented in different parts of the state. So you can see in orange here that indicates that the pollutant of concern or nutrient pollutant of concern is nitrogen for the Connecticut River. The blue indicates the pollutant of concern is phosphorus for Lake Champlain and Lake Memphremagog. And these are the number of projects that were implemented. In the Lake Champlain Basin, we were able to quantify pollutant reductions for 51 of those projects. 132 we were unable to quantify a pollutant reduction for. So while it may look like the phosphorus decreased from prior year, there were just more projects that were completed in those areas where we're not able to quantify a load reduction, but we're working towards being able to quantify all of those reductions. So this table on page 66 of the investment report summarizes the estimated phosphorus reduction by the different clean water project categories. And so while in 2016 we collectively were able to reduce and quantify a reduction of 992 kilograms per year, it dropped off quite a bit in 2017 to 366. A big part of that is that we weren't able to quantify everything, so we know that this is vastly underreported, and we're working on filling in some of those gaps as I had explained. But the important thing to note is that a lot of these structural practices, like a forested buffer or a stormwater treatment practice, those are going to function over multiple years. So the reductions that we achieved last year, most of those are still helping us this year. And we're going to be tracking into the future the cumulative results of those projects. And we're also working on a way to go back and verify that prior constructed projects are still operating the way that they were intended to operate, so that we're not giving credit to a project that no longer exists or is fallen out of disrepair or fallen into disrepair. Question?
Are these numbers based on actual data samples from the water, or are they based on models?
This is based on models.
So
this is based on the modeled loading rate. So
So do you actually keep data on the actual phosphorus in the water, on actual data?
We do have long-term monitoring programs that track the trends of nutrient pollution in different tributaries going into Lake Champlain and in other parts of our inland lakes as well. So we couple this with those monitoring data to try to get a full picture of what's going on. And we've also began to fund more projects where we're helping local partners do monitoring before and after a project is implemented, so that we can see actual in-stream or in-lake benefits of these projects at a more local scale, because it's going to take a really long time for us to see these results in water bodies like Lake Champlain or Lake Memphremagog, and Lake Carmi and the Connecticut River, Long Island Sound, it takes a really long time to turn that curve, and it requires a long-term maintained investment in implementing these projects. So this modeling helps us to provide some level of accountability in the meantime before we start to see the changes happening in those larger water bodies.
Do you have the actual data sampling available for people to see?
So they are, I believe they're in the process of being finalized over the course of this winter, and we plan to include a summary of that in next year's investment report, and there will also be reports posted on those results. So we'll be sure to make that available to
And that will go back multiple years?
I believe a lot of the monitoring happened in this prior year, this prior field season.
Just started this last year.
Oh, no.
In Lake Carmi, it's been going over a decade, so we have a lot.
Yes.
So I'm just interested in actuality, because we happened to be at a meeting where there was rejoicing, because the model showed it went down, but the actual data samples showed it went up. So.
Right, so the
issue with, we know you're doing the best you can with your models, but.
the monitoring.
That's right.
The monitoring I just mentioned that happened over the last year was just the pre and post project implementation monitoring, but there's been much longer term monitoring going on for decades that you were mentioning. So sorry for that.
So nothing in this year to see actual data, but next year we'll actually see what the sample says.
For
Versus
specific,
specific problems.
yes, there'll be more like case studies just to demonstrate the benefits. Yep, yeah.
So tie-in comment to your discussion of modeling versus actual data. In this water quality realm, developing a computer model, and then you were saying coupled with the monitoring data, getting over time successive annual water quality data and going back and calibrating the computer model to fine-tune it based on what's coming in annually with sampling programs. Getting that entity, person, whatever, back to changing the model, of course, is expensive. And it's another step. Generally, there's some kind of a funding identified to develop the model, and then requires future funding to calibrate the model, in addition to the money spent taking the water quality data. So I don't know what the percentage is, and I don't know if you have an idea of how many of these models are actually followed up with calibration over time. I think that's getting to your underlying question.
So the models that we're using to estimate pollutant reductions are calibrated to the modeling that was done for the Lake Champlain TMDL and the Lake Memphremagog TMDL. So it is relatively up to date, and that was calibrated based on actual monitored water quality data. And you bring up a good point that for us to update those loading rates in the future would be expensive and would take time, and that may happen. I don't know of any plans for it to happen right now.
Question from Becky Tharp. What monitoring efforts have you funded with local partners at BMPs? Are you talking about long-term monitoring efforts or BMP monitoring to illustrate performance?
So through the Vermont Clean Water Fund, there was an allocation that made funding available to local partners to be able to go out and do pre and post project implementation monitoring so that you can see the change in water quality at the local stream level before and after a project is implemented. So there have been, I think, a handful, I don't know the exact number, I think maybe 10 small grants that were made to local partners to do that type of work. And they are wrapping up those efforts throughout this winter, and we plan to summarize the results of those projects in the coming year. And there was also additional funding made available, so there will be a whole nother set of those projects starting up again in this coming field season.
Okay, great, thanks.
Okay. So one new feature that I find very exciting in the investment report, if you look at Appendix A, we now have a summary at the watershed scale. So for each of our major river basins in the state, we are now highlighting where the watershed is located and the towns and county boundaries within that watershed, so people can start to understand where the watershed boundaries are within some of the boundaries that they're familiar with, like their town or county boundaries. And then we summarize the dollars that were awarded to projects within that watershed by sector. So we have this available for all of our major 15 river basins at the end of the report in Appendix A. So this shows dollars awarded in State Fiscal Year 17, and we also break down our project results by watershed here. So this shows all of the projects completed in the Lomoille River watershed in State Fiscal Year 17. So this is a new resource that's available, and it, I believe, will also be linked to from the Tactical Basin Plan. And so I just talked a lot about the report, and I just wanted to share a little bit more information about our tracking system and how we back that all up. So over the last couple of years, we've been developing this tracking system. It houses everything from our Tactical Basin Plan implementation tables. Those are a listing of priority projects that are queued up for either design work or implementation. And it also is used to track work that is completed through funding and regulatory programs. And within this database, we also have our BMP Accounting and Tracking tool, and that is the modeling tool that we were talking about earlier that helps us to estimate pollutant reductions associated with these clean water projects. And we use this database here at Agency of Natural Resources to track our projects, and then Agency of Agriculture also has their partner database that they're using to track agricultural practices, and they send me their data on an annual basis. And then we also have the project database at VTrans that was developed to track the projects that they fund. So once a year, we bring all of those data together and compile the results to report on in the investment report. And now I just want to turn it over to Helen, who's going to talk a little bit more about our BMP Accounting and Tracking tool, and then she's also going to share an update on our new dashboard.
Okay. Hi everyone. I'm Helen. So as Emily had stated before, I'll talk a little bit more about the BAT tool, or the BMP Accounting and Tracking tool, that we use to estimate phosphorus and nitrogen loads that are removed by a specific BMP. For the most part, we're looking at structural BMPs like stormwater treatment practices, some buffer planting practices, and some agricultural practices. So what we can do through our funding program is we get a report on the BMP information that we need to calculate phosphorus. So, for example, we need the acres that were treated, the type of land use, some BMP characteristics like the storage volume or the infiltration rate of a practice that gets input into the tracking database, and it spits us out a load. I'll go show you actually what our internal database screen would look like. We have kind of location information up here, and we input the land use, the acres of each type of land use, and that it calculates the phosphorus load coming off of that land. Then as we input the BMP, that calculates kind of the reduction in the load. So that is represented at the bottom here in the loads and reductions section. So for this particular bioretention, we had a load reduction of about 4 kilograms per year.
Question from Becky. Does the BMP tracking reporting tool use the simple method for calculating pollutant removal performance?
They do not use the simple method. That's a different method. And this is not quite as simple as the simple method.
She's asking do you want to follow up with her offline after to get into the details of the method? Or
Yeah, I guess it's based on BMP performance curves. Tell me if I'm wrong.
Yeah. Yeah, so first, the loading for the area treated is based on the modeled land loading calculated under the Lake Champlain TMDL or the Lake Memphremagog TMDL. So these loading rates are calibrated along with the modeling that was done for TMDLs. So it's a little bit more specific and calibrated than what you would get out of the simple method. And then for the stormwater treatment practices in particular, they're referencing the performance curves that were developed with EPA funding through the UNH Stormwater Center primarily. So they look at things like the storage volume, the infiltration rate, if applicable, to figure out what point on that performance curve it should reference to get the estimated % reduction on an annual basis.
All right, great, thanks.
So now we will switch gears a little bit and we'll start talking about the Clean Water Projects dashboard. So the dashboard is going to be directly linked to our current tracking database, Watershed Projects database is what we call it. Right now, it looks like this kind of first picture, and there is a part of it that's public facing that can be accessed, and you can search for projects. It kind of gives you a limited information about the projects, the titles and the types and the locations of the projects. But what we have currently kind of completed, and we're still kind of tweaking it, but we're into this phase 1 of the dashboard, which involves these individual project summary reports. So each project that was reported on in the investment reports from 2016 and 2017 that Emily was just talking about, you're able to click on one of those projects and it'll bring up this individual project summary. The summary includes information about the project, descriptions, the results of the project, and sometimes pictures. So that's actually available, and I'll go to our website in just a minute. But what we're working towards is our future state is actually, so right now we are only able to show you projects that have been funded through ERP grants through our database, because that's kind of where we have most of the information. But we are going to be working with our partner agencies like the Agency of Agriculture and VTrans to get their data into our database so that we can kind of integrate it into this ultimate version of the dashboard, which will show all clean water projects throughout that have been funded with different monies from different agencies. Ideally, it'll have a map of where the projects are, so you can kind of zoom and filter and click, and it'll also have some, it'll be able to kind of aggregate the data, show you graphs of groupings of projects, types, or locations. So I think that's going to be really exciting. Once that comes out, we're going to be working on it throughout this year. We'll let you know once we roll that out. So going into what we have rolled out today, this is just an example of one of the individual project summaries that we can now make available to the public. It has the project type, name. We have a little map of where the location of the project is. And it'll have, so like the project status, this one has been completed, the results, including phosphorus reduction, if that was a project that we could calculate it for, in the performance measures. A brief description of the project, and then we tried to put in pictures for all projects that have been kind of implemented on the ground, and that we had before and after pictures for.
So, for example, photos won't be available for design because it doesn't exist on the ground yet, but for constructed projects, we have photos.
Right. So this is available on our website. If you go to the Clean Water Initiative website and you click on the projects button, it will bring you here. So yeah, and then these two links are the ecosystem restoration project summaries for 2016 and 2017 investment reports. I believe, and when you click on this will bring it up. I believe it brings up all the projects. So anyway, so yeah, this is what it will look like for now, and it'll have project name, partner, and kind of the location, project type. Oh, this is good. And you can kind of scroll through, you can sort using these buttons, and then if you, all the way over to the left, let's find a good one. You can click the view button and it will bring up the project report. Look like this. You can like export it to a PDF if you want using this button. So this kind of a report is available for all of these projects. Some of them are still in progress that we'd funded and they're still being implemented. But there's about 225 projects on this list. That's really all I had. So if anyone has questions on this, let me know. And these are some websites for more information. Our website's the first one, and then specific to the reports and to the projects are the next two links.
So just a couple minutes for questions,
but
yeah, we pretty short on time, but so yeah, if folks have questions in the room or online. I guess one question online from Charles Baker, will this list include road erosion projects that are done with municipal funding?
We are still working out exactly how we're going to be displaying the results of municipal road general permit implementation. If they are doing work to comply with the permit and they also receive state funding for it, they will definitely show up here. And if it's just work they did on their own, I expect we'll have some other kind of a dashboard to help communicate progress implementing the permit program as a whole. But that's still in the works. Yeah. Any other questions? Great.
Okay, yeah, I don't see anybody typing online. So thanks very much to Emily and Helen for presenting. And if there are questions, follow-up questions, contact information is up on the screen. And I also just want to highlight that Jim Ryan is going to be doing the next Clean Water Initiative lecture. That'll be February 8th, and that'll be on the municipal roads general permit. So thanks for joining us. You want to hit stop.